I have the two new capacitors for the bias circuit, and these are twice the capacitance of the ones that exist in here. They're 100 microfarads, and I wanted to get some baselines before I take these out. And what I've got, first of all, is I've got the bias set up, for better or worse. 1.48 in this channel, 1.48. So it's evenly biased. The current is being evenly distributed amongst the two pairs. I say that because the current is not being evenly distributed amongst the tubes. That's not how this set is designed. I have right now my oscilloscope coming off of the selenium rectifier, and we have a DC voltage, and it is averaging right now 62 volts. And we can get a measure in, and we're seeing between neg 61 neg 62. I do have the oscilloscope in play here, so it could be causing somewhat of an effect on it. What we're going to do is we're going to monitor that voltage. We'll take a good look at it. We can all see it now. And I'm also going to measure the voltages at the different points on here between the capacitors. And finally, the voltage coming out of there, pins 1 and 2, that also follow pins 22 and 23, and then the voltage to the capacitor, to the tubes, to the EL34 is the bias. And we're going to see if there are any major characteristic changes between the old but closer aligned capacitors to the double the size capacitors that I'm about to put in there. So let's take a look. I should point out before I do that in case I did not record that, the bias I believe is 148. Yeah, 148. So we're going to take some readings along the rail here and see what we got. So after this first resistor, we're seeing a voltage drop of neg 35.9, negative 36 volts. And I also see against this resistor, neg 24. But what we're really interested in is the value that's coming down to the potentiometer, which is neg 36. And we follow that to what we have our pot set to. The middle point here is neg 30. And then finally making our way out to the tube, the negative bias, we see negative 29.8, and that's what we're going to measure at the tube. Off of this one, negative 29.8, and then we have a very small resistor that actually takes it to the grid, and it's only marginally lower. 29.80 versus, well, it's about the same. It's very low resistance, so it's definitely not a voltage dropping resistor. But we have that information. We're only going to use the top as a reference. We're not going to measure the top and the bottom to do this. But what we're also going to look at, obviously, is how our DC looks. I don't know if these capacitors are going to improve this DC. This DC is for bias. You can see a bit of a sawtooth through it. It is just one selenium rectifier. It is not a full bridge rectifier, so we're not going to see anything like that. But let's put in the new capacitors. We're going to bring it back up to temperature, and let's see what we got. I've replaced the old capacitors down here with the new ones. The 100 microfarad, 450 volt. I'm going to do some quick checking, make sure everything's good, no shorts, no nothing. And then what I'm going to do is I'm going to bring this up, monitoring the bias voltage, because I do expect a change. If the bias voltage creeps too high too quickly, I'm simply going to shut it down, crank them back, and then bring them up again. But I'm hoping to avoid that, because what I would like to do is make a comparison where nothing was changed with respect to voltage or anything else on this setup except for those two capacitors. I'm going to reconnect the oscilloscope to the DC side of the rectifier and see what we get. I've given the amplifier ample time to warm up, no pun intended. And I'm reading 149.9 on the left channel. I don't know if you can see that. There you go. And the right channel, 149.3. A small enough variation to say that there was really no variation. Obviously, this wouldn't be complete without going through the whole thing, but I want to talk about this right here. Now, Naturally, this is not 5 volts. I've turned it to bring the waveform into the picture because I wanted to see what the DC looked like. And I guess that's subjective. Coming through the rectifier, it may be smaller. I don't know. I'm going to review footage of this movie and the last one to make that determination. What's really important, what I haven't captured on film, is when my air conditioner clicked on, not within the movie, but before I had removed the capacitors, I saw about 20 volt deviation bounce up and then back down and then recover. And while I was working with this, I noticed that when the air conditioner turned on, it was less than a couple of volts, maybe 3 volts deviation, bounced down just a couple of volts and then leveled out. So this could obviously be because the capacitance is greater, that it's allowing for a greater amount of stability for things like that. And it could also be because the old capacitors were trashed. But it was very interesting to note that the power fluctuation, seeing my compressor turn on and then seeing the fans for the air conditioning system turn on, that such a difference has been made in how that current draw in the house affects everything else with regard to this unit and the power coming in from the Variac. So that's pretty cool. So, like I said, you know, as it heats up, it starts to come into its own, but there was no real great deviation here. I'm seeing, you know, 1.5, 1.51. I think I was seeing something slightly lower by 0.02 volts or something like that. So I'm going to take some measurements now with the board and see what we're getting. Just to capture the voltage drops that we had last time, I have the rectifier coming in and coming across this first resistor, and we see neg 36.5. And I also have the voltage from the second resistor, neg 25.23, coming to our but this is going to be the same as that one. This neg 36. This one here is neg 31.27, which goes into here, and our product on pin 1 is neg 30.3, and pin 2 should be neg 30.3. Off to the tube itself, neg 30.3, and inconsequential voltage drop over here. There we go, neg 30.2. So that's the voltages, that's the bias circuit, and that's the bias circuit change with the new capacitors. Rectifier is reading about 420 with 360 in. So maybe a little low, maybe a little tired. I don't know, but we're gonna go with that. And what we're gonna do is first of all, we know that pin 8 right there represents our D rail for DC. So we've got that measured. So I could just write that down. What we're going to do is we're going to look at A, B, and C. There's D coming right off 8. We're going to measure A, B, and C and see what we get between those voltage drops between those resistors and annotate them. So here's our D voltage right here, which is about 424, 423. And that's our D, and it comes down and it goes into this RF choke over here. This presence is also 423. But if we measure right over here on the other side, we'll see 411 right there. And that right there represents our C voltage of 411. And B makes its way across with a 6.8 k ohm resistor. So B comes along on the rail right over here into the next resistor. And from that we can derive what the B voltage is. And we see that's 397. 397 for B. And then we have a 22 k ohm resistor from which we get our A voltage. So we're going to come up right here and just measure that right there. And we see we get 346. So there we have our 3 measurements for A, B, and C. And then we could further see how they make their way through the circuit in the other diagram where they're injected into this board here. Well, we tested everything thoroughly. I didn't get the voltage drops I was really looking for on the A, B, C, and D. And D is simply a matter of what's being delivered from the rectifier, which is a bit weak. Interestingly, as it comes out of the RF choke, it comes down and becomes the C voltage right here. And the C voltage was only off by a couple of volts, almost spot on. The thing is that the B and A voltages that I expected to receive here were a little bit higher. What I think happened here is that D is delivering something that's a bit weak, and that has to do with the rectifier. The C voltage is actually going to the EL34s that are currently in there. B and A, however, go to a different area of the schematic. And B and A come out here, and they serve the 7199s, which I didn't have in. So that's sort of like in open, because the tube is not there, and A and B are coming off here, and they have their own further voltage drops. We have a capacitor over here, so there's no DC coming across here, and it's going straight to the plate. Not really sure. I'm gonna pass that one back to the group to find out. What I could do, because I don't have my converters yet for the new tubes, is I can go and put in 170/199 and redo that test to see if I have any sort of appreciable voltage drop. And if I do, if I see it being pulled down by one tube, then I'll be satisfied to know that when I get the other tubes in, that we'll be matching those voltages correctly. I have been measuring the obviously the two resistors here are also important, and they're measuring spot on with the values that they're supposed to be. So I'm going to rule out those resistors and say that the 7199 tubes are needed to complete the testing of the DC rails.